This call is now being recorded.
Good morning, friends. Today we are going to talk about a topic on Anova, and we are going to take a numerical example. Along with that one, we will try to find out uh, the results of Anova, and we will even do numerical calculations by using manual method. Okay, so that is our agenda for the day. Let's go into the details. So ANOVA is nothing but analysis of variance. So what do you mean by analysis of variance? So before I go into uh, the theoretical part of ANOVA, let's take up a small numerical illustration or a situation and try to work out ANOVA, that is analysis of variance on that particular numerical example. So in this particular example, if you are able to see the PPT, Excel sheet, uh, there are 6 different methods of teaching which are adopted by a particular college or an institution, academic institution. For example, one method of teaching is by using only blackboard. The second method used in solving in classroom teaching is using PPT, by showing PPT. The third method of teaching or mode of classroom teaching is using showing videos to the students, and the fourth particular mode of classroom teaching is blackboard and PPT. Okay, combination of 1 and 2. The fifth method or mode of classroom teaching adopted is PPT plus video. By showing the PPTs, by showing videos, they are trying to judge whether the students are receiving what they are disseminating. Okay, on the same way, the sixth particular method which is adopted here is board, by using a blackboard as well as PPT and as well as videos. So they're using combination, blend of blackboard teaching, PPT, showing PPTs to in the classroom to the students, and by showing videos and trying to guess how well the students have understood. And subsequently, after each mode of classroom teaching, the concerned faculty is conducting examination of a particular subject, and this examination is administered to 25 students of the class. uh, the sample is 25 students. Okay, so when they are using blackboard when they are using blackboard, the number of marks secured by the students, student 1 2 3 4 5 6 so on and so forth up to 25 out of 50 marks. Okay, this is examination conducted for 50 marks. Okay, so all the students have secured 20 marks. Okay, just for hypothetical, I have taken these marks on a hypothetical basis to make you understand the concept of ANOVA. There is no other intention, but we can change these figures, and even on these change figures also we can calculate ANOVA. If time permits, I will show by changing these figures of the marks secured, because this year in each case it is constant like 20. In the subsequent examination, which was conducted after the mode of classroom teaching adopted was PPT, the students 1 2 3 4 secured were 30. So all the students secured 30 marks. So comparatively, if you look here, previously the student has secured 20 marks, subsequently he has secured 30 marks. So quite an improvisation is there. So yes, it will, on the face of it, it is apparent, it is palpable that PPT method of teaching is comparatively good in relation with, in comparison with blackboard teaching method of teaching. Now, in the subsequent third situation, they have used videos to which were administered in the classroom. They showed videos pertaining to the subject, and subsequently they conducted an exam on the same subject, and the students have failed. The students have got 35 marks each. All the students from roll number 1 to roll number 25. Roll number 1 to roll number 25. Now, subsequently, the fourth situation, the fourth case, they use Blackboard as well as PPT in the classroom teaching, and subsequent to that, the teachers conducted examination. They administered examination to the students, and the students got 36 marks in from roll number 1 to roll number 6. So if you look here, there is a quite substantial improvement from 20 to 30, 30 to 35, and 35 to 36 in all the cases. So is on the face of it, it seems that there is a variance or there is sorry, there is a variation in the marks. There is an increasing trend in the marks. Now, in the fifth particular situation, they adopted another mode of classroom teaching by using PPTs and by showing videos of the concerned subject, and subsequently they conducted the examination of the same subject, and it was seen that the students have secured 38 marks from roll number 1 to roll number 25. Lastly, lastly, in the sixth situation, the teachers adopted Blackboard as well as PPT as well as videos in the classroom to make the class very interesting, and they thought that this could enhance the learning levels of the student. And subsequently, they conducted examination, and the students secured 42 marks in all the, as far as the concerned 45 students were 25 students were concerned. So the question arises: is there a variance as far as marks are concerned between the different modes of classroom teaching? Okay, for example, is there a difference between uh, marks secured by when PPT was used? Is there a subsequent substantial change as far as comparison of Blackboard teaching to PPT teaching, and so on and so forth? So we want to find out, is there a variance between these marks of student 1 to student 25 in all the different methods of teaching which are adopted? Okay, we can have so many numerical examples as far as Anova is concerned. So I could take a small example in this particular session, where what is the marks secured when different modes of teaching methodology are adopted. So please remember, if you look here carefully, the results, the dependent variable, I will call it. The dependent variable is the marks, and the marks are in number. The marks are in number. So this is one. Number two, there are different methods of teaching. Teaching one style, teaching 2, 3, 4, 5, and 6. So these are what you call these are all what you call quality of teaching, the type of teaching which is adopted, the type of teaching which is adopted. So one of the basic conditions is that independent variable should not be numeric, should be what you call a nominal, I will call it, and the dependent variable, which is a measurable variable, which is going to be affected because of the independent variable, should be number in nature. So all the marks are number in nature if you look carefully, numerical in nature. Number two. Number three is these are the samples which are collected, and we are working on these samples. Now what we are trying to find out is whether there is a difference in the marks secured by the students uh, when when different classroom teaching methods uh, are adopted by the institute. So hypothesis is marks secured uh, when the student was taught by using Blackboard and so on and so forth are not same as far as null hypothesis are same as far as null hypothesis is concerned. Whether it is Blackboard method of teaching or PPT method of teaching or video method of teaching or Blackboard and PPT method of teaching or PPT plus video method of teaching or the sixth method, the assumption is that there is no variance or there is no change in the marks. The marks are same. This is the null hypothesis as far as ANOVA is concerned. The null hypothesis. Okay, as far as alternative is concerned, the marks secured by the student under different methods of teaching are different. So this is what is the null alternative hypothesis. Now, when this is a kind of situation where the dependent variable is a number in nature and the independent variable has a nominal in nature. Okay, number two. Number three, when the groups are more than two, when the groups are more than two. So this is Blackboard is Blackboard one group, PPT one group, video is one group, Blackboard and PPT is one group, PPT and video is another group, and Blackboard and PPT and video is another group. So we got more than two groups. We have a a group of almost six. So group 1, group 2, group 3, group 4, group 5, and group 6. If it is a case of only two groups, then we will use a paid sample t-test, because we are comparing the marks of student 1 at the time when when was taught by using Blackboard method of teaching, with the same student, how many marks he has secured when he was taught by using PPT. So this is marks secured by the student before and after, you can assume. Okay, if there would have been only two groups, then we could have used a t-test, a paid sample t-test. But we have more than six groups. We use when there are more than two groups, we will use ANOVA to find out whether there is variance in the marks after or before or in different methods of classroom teaching. So ANOVA is used. Now we have to conduct on this particular data a test called as ANOVA test. So let's carry out ANOVA test on the given numerical example. So what you have to do, you have to download. I am doing it on Excel. Please remember this particular session. As far as ANOVA is concerned, I am conducting or doing on the statistical calculations as far as ANOVA is concerned by using a data analysis tool of MS Excel, on MS Excel. Okay, so already I have uploaded a video on how to download uh, data analysis tool pack of Excel in Excel. Okay, so you can visit my YouTube and you can get an understanding about how to download the tool Excel tool data analysis tool pack in Excel. Now let's conduct ANOVA. Let's conduct ANOVA on this set of data. So don't look at this one. I'm going to show you all the results and how the results have come. That is the focus of today's session. So on this data, I'm going to conduct ANOVA. Okay. So what you have to do, you have to go to data. You have to go to data. Here we have data analysis. If you go to data analysis, you will get a pop-up box will open, and you will have so many statistical tools which you can use for your purpose. But in this particular case, we are going to use ANOVA. So single factor ANOVA. We have ANOVA two factor. We have now got correlation, covariance, and so on and so forth. But our primary motive, as far as this session is concerned, is ANOVA. So ANOVA, you select ANOVA and then click on OK. So you will get a pop-up box like this. So input range, you will be first asked input range. You will be asking input. It will ask you an input range. So it means you have to give the input range on which ANOVA is going to be worked out, or ANOVA is going to be calculated. So what I'm doing, you just look at this. I'm selecting from this point to this point and dragging downwards till the end. All the data is collected. So please remember, in this selected area, if you can see, all the numerical values as far as marks are concerned are selected, and the different methods of teaching also have been selected. So this is number one. Hope you have understood it. Now there are two questions. Now come down to grouped by. So whether you want to group it by what do you call, column wise or row wise. So I have grouped them by column wise: Blackboard, PPT, video, Blackboard and PPT, PPT and video, and so on and so forth. So it is grouped by column. So I have clicked on column. Okay. Now the third one is labels in the first row. Is there a label in the first row? Yes, this is the label in the first row. This is the label in the first row. So I have selected label also. I have selected even the label also. So you have to tick on the whether you have selected table or not. Yes, label or not. Yes, I have selected the label also. So I selected label. Alpha is 0.05, means I am conducting this particular experiment at a confidence level of significance of 5% or 95% degree of confidence. Okay, so 1, 2, 3, 4 are clear. Now where do you want the output range? I want the output range in this particular sheet itself at the cell G3. So I will say I have selected this and I have put G3. Okay, so I used G3. If you look here, G3, then I will say OK, and it will, and you will get the output like this. This is the output. This is very, very important. This is the output. Now look at the output. I have marked it in blue color. If you are able to see, I will show it in okay, light. I will violet color. So this is the output you get. This is the output you got by using Anova. So such a simple tool and very, very easy to be, very, very easy. We can use it, and very, very what you call, sophisticatedly we have to use it. Now let's look at the summary. This is the summary 1 and Anova table 2. Now today we are going to talk about this part. I'm going to talk about this part of the output, which is marked in yellow, red color, sorry, and this particular one. So this is the discussion, and the remaining I will take up in the next session. So how did we arrive at this particular figures? So how did we arrive it? So Blackboard. So groups. How many groups are there? Blackboard, PPT, video. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Correct. Okay. Now, how many counts are there as far as Blackboard are concerned? There are 25 students in each of the cases. So you got 25 in all the cases. So no problem. So no problem. This is also over. This is also okay, clear. Now let's look at the other one. What is the sum? If you total 25 students in the first case have got 20 marks each. So 20 into 25 is 500 marks. In the second case, 25 students have got each 30 marks. So 750. That is sum I am doing. Now in the third case, when I am using video as a method of teaching, the students have secured 35 marks each. 35 into 25 is 875. So hope you understood this part also. Now 36 marks. In the fourth case, when Blackboard method of teaching and PPT method of teaching was adopted, each student secured 36 marks. And how many students were there? 25 students were there. So 36 into 25, 900 marks was the total. That is the sum. Hope you understood this. So subsequently, for PPT and plus method, as well as this last method also, you can calculate on the similar lines. So this part is now loud and clear. Loud and clear. Hope so. This is also clear to all of you. Now next one is average. Average is nothing but sum divided by count. So 500 divided by 25, 750 divided by 25, 875 divided by 25 is equal to 35. So you will get this average marks. Variance. Is there a variance between this marks this marks, everybody got 20 marks, so there is no variance. In the third case, second case also, everybody got 30 marks, so there is no variance. In the third case, everybody got 35 marks, no variance, so zero variance. So for the fourth, fifth, and sixth case also, there is no variance. So there is no variance between the marks secured, uh, okay, within the group. Okay, this is within. Now this is very important. Now we are going to talk about this particular part, which is very, very important. So I am increasing the font size. So this part is very important. Now how did we arrive at this particular one? So this is the discussion what we are going to have now. Okay, let's talk about this one. Now if you look at, this is called as the Anova table. This is part one summary. That is, we can tell this, we can use the name descriptive statistics for this particular part. For this particular part, I can use descriptive statistics as the name, and for this, I can use the word Anova, results of the Anova, results of the Anova. So these are two different tables. So we have seen already descriptive statistics. Now we are going to talk about the Anova table. How did we arrive at these figures of, and what do you mean by between groups? What do you mean by within groups? What do you mean by total? What do you mean by SS? What do you mean by DF? What do you mean by MS? And all that stuff. Okay. This we will subsequently take up. Our concentration is how did we arrive at these figures of 7388, 0, 7388, 5, 144, 149, and all that stuff. Okay. So let's solve the problem. Now 7388. Before I go into what is seventh, how did we arrive at these figures? Let's talk about the between groups and within groups and total and SS, DF, and MS. Okay. Now between groups and within groups. Now if you look at this, if you look at the blackboard, how many marks are secured by all of the students? Every student have secured 20 marks each. So this is a case of there is no variance within the group. There is no variance within the group. This is group 1. This is group 1. This is group 1. Group 1. This is group 2. This is group 2. This is group 3. This is group 4. This is group 5. So I'm talking about only one first group, blackboard. Blackboard. Is there a variance between the marks secured by each student? No, every student has secured 20 marks, so there is no variance. So within within the first group, how many students are there? There are 25 students. Is there a variance between the group marks secured within the group? No, there is no variance. All the students have secured absolutely same marks, so there is no variance. This is called as within group. This is called as within group. Within group. In the second case also, PPT, when PPT was used, all the students secured 30 marks. As far as group 2 is concerned, is there any variance within the PPT group? No, zero. Let's talk about the third group. When video was administered in the classroom for teaching learning methodology, as a teaching learning methodology, in this group 3 that is video used, all the students secured 35 marks. So there is no variance within the students marks secured as far as within the group is concerned. In the subsequent cases also, you got the same marks. So the variance within the group means with only one group, only second group, only within the third group, only within the fourth group, only within the fifth group, only within the sixth group. So there is no, that is the meaning of the word within group. Okay. Now between groups, is there a variance? Now what do you mean by this? Between groups variance, within group variance, between group variance. Between means between blackboard and PPT, between blackboard and video, between blackboard and PPT, between blackboard and PPT and video, and other combinations. So 1 with 2, 3, 4, 5, 2 with 3, 4, 5, 3 with 4, 5, 6, so on and so forth. So there are so many combinations. There are so many combinations. So between groups, I am observing, is there a marks, any variance is there? Okay. So let's look at the first between blackboard and PPT. Between blackboard and PPT, is there a difference in the marks? Is there a variance in the marks? Yes, on the face of it is observed that the student 1 secured 20 marks, when Blackboard was used, but he secured more marks, that is 30 marks, when PPT was used. So between these two groups, the same students have secured more marks. So that is the meaning of between groups. So you can what do you call, between one student number one, Blackboard and video, 20 marks and 35 marks. So between one group and between the third group, the same student has secured 20 and 35 respectively. Blackboard and Blackboard plus PPT, 20 and 36, the student one has secured. So between the groups is there a variance, and it is on the face of it, it is found yes. It is found yes. Please remember, the formula for ANOVA is between groups by within groups. Okay, between groups by within groups. So today we are not going to talk about ANOVA, but how we can do ANOVA in Excel, and what are the results, whatever are the results which we have been derived from by using MS Excel data analysis toolbar. We are going to discuss on those results. So hope you have understood between group, within group. Now the sum of between group and within group is called as total. The total of between group and within group is called as total. So hope this is also clear. So this part is clear if I am confident. Okay, so this is over. Now let's talk about this one. Let's talk about this particular part, which is SS, DF, and MS. Okay, so let's first I will talk about uh, DF, that is degree of freedom. Degree of freedom between groups. The formula for between groups, DF, degree of freedom, is total number of groups minus 1. So how many groups are there? Group 1, group 2. If you look, Blackboard is one group, PPT is one group, video is one group, Blackboard and PPT is one group, PPT plus video is another group, board, classroom, Blackboard and PPT and video is the sixth group. So we got 6 groups, and it is normally shown by the symbol K. K is equal to 6. K is equal to 6. So because the groups are 6, K is equal to 6. K is equal to 6. But when I am talking about between groups, the degree of freedom, it is given by the formula K minus 1. K minus 1. That is equal to 6. 6 minus 1. 6 minus 1 is equal to 6 minus 1 is equal to 5. Okay. So you got this 5. You got this 5. Hope you have understood it. So the simple answer to degree of freedom, as far as between groups, is just you have to remember how many groups were there, and deduct 1 from that. So in this case we got 6 groups. I deduct 1 and I will get the degree of freedom as 5. Okay, as 5. Hope this is also clear. Hope this is also clear. I will format the cell. So this is 5. Now within the groups, what is the degree of freedom? So it is nothing but, if you look how many elements are there, total there are, if you look in every group there are 25 members. 25 members. So how many groups are there? There are 6 groups. So 25 into 6, there are 150 sample, 150 numbers on which I am going to conduct uh, ANOVA. So here n is equal to the number of total number of observations. The total number of observations is equal to n is equal to 150, because it is nothing but 25 students were administered exam, and there were 6 groups. So 150 marks on which ANOVA was conducted. So 150. So how did I get at this 144? To find out the degree of freedom of within group, formula is n minus k. What is n? Number of elements. K is number of groups. So it is 150 minus number of group is equal to 6, is equal to 150 minus 6 is equal to 150 minus 6 is equal to 144. So hope this is also clear. Next one, total, degree of freedom of total. So total is, you have to just multiply degree of freedom between groups and degree of freedom within groups. You, if you just sorry, addition, add it. If you conduct addition, you will get 5 plus 144 is equal to 149. So this is also clear. Now our concentration will be finding out this figure. How did you get the between groups, some between groups, a numerical value of 7388, and within groups of 0 and total of 7388, 7388. So let's calculate one by one, because that's the main calculations which we are supposed to take up in this particular session. So let's take the calculations. Now here I have done sum of squares total. This, if you look here, this is the area where I have calculated sum of squares. Sum of squares. So let's talk about this particular topic, this particular part of our discussion. Now here, first and foremost, I have to find out the grand mean. Grand mean. Now, what do you mean by grand mean? So grand mean, I am showing the calculations. Grand mean is equal to, see, there are 150 marks here, 150 marks. Okay, if you look at this area, in at this particular area, there are 150 marks. So you have to sum them and divide by total number of observations. So total number of observations are 150, and let's total it. So total is equal to sum, and I'm summing all this. Okay, from here I'm summing all them. I'm adding. So I will get 5025 as a total mark of all these 150 observations. How many observations are there? 150. Therefore, grand mean is equal to, now mean. What is the meaning of mean? Sum by observation. That is 5025 by 150. You will get 33.35. So this is for step number one. So you got 33. If you look here, you got uh, grand mean of 33.5. Grand mean of 33.5. Hope this is also clear. Hope this is also clear. So this is the grand mean. So to find out the sum of squares total, I have to find out the grand mean. Now, what do you mean by sum of squares total? Now, I forgot to tell about this one, SS. SS is nothing but sum of squares. So we are supposed to find out sum of squares between sum of squares. We have to find out sum of squares between, sum of squares within, and sum of squares total. So we have to do sum of squares of total. We have to do sum of squares of uh, within group, and we have to do sum of squares of within the groups. Okay, so all these three things we have to conduct. So one is sum of squares between, one is sum of squares within, and one is sum of squares total. So sum of squares total was 7388. How did we arrive at this one? So to find out that, first and foremost, you have to find out the grand mean. We have to find out the grand mean. So we have done the grand mean. Okay, we have done the grand mean. So let's go to this part where I have calculated the sum of squares total. So here, what I have to do is, I will just copy this one and I will show it in the next sheet. This will be very convenient for you. So here I am pasting, and I got the grand total, grand mean. If you remember the grand mean is 33.5. So I will put here 33.5. So what do you mean by sum of squares total, which is called as SST? And in this case, we got some figure called as 7388. I got 7388. How did I arrive? I got 7388. How did we arrive at this figure? So what I am supposed to do is, sum of squares total I am conducting. It is nothing but the individual marks and the grand mean, how they are deviating, or how much is the variance. That is the meaning of individual elements of SST. That is, in the first case, the first student got 20 marks, the second student also got same marks, so on and so forth. When the first method was used, when the first method was used. Okay, I will write the method 2, 3, 4, 5. What you remember these methods? One is PPT, video, combination, all that stuff. Okay, so 20 marks was the first. The student got 20 marks when first method of teaching was used. Now I'm trying to find out in SST how much it is deviating from the average, the total grand mean, average of the grand mean. Okay, how much this 20 marks is deviating from grand mean. So that's the reason I am put 33.5. In the same way, second student, how many marks he has secured and how much is deviating from the grand mean. So I put all the grand means. How many grand means? 6 grand means I have to put. So this guy is, this marks are deviating from this marks, these marks are deviating from this marks, these marks are deviating from the grand mean, these marks. So these are all grand means. Okay, why I have taken, you have understood it, grand mean. Okay, hope you have understood this one also. Now, so 20 minus 33.5, 30 minus 33.5, 35 minus 33.5, 36 minus 33.5, 38 minus 33.5, 42 minus 43.5. Otherwise, for all the individual elements, we are going to take a difference with the grand mean. So here I am going to find out this minus this one and enter. And I will drag it to the bottom and up to 6 columns, because there are 6 different methods of teachings adopted by the college. So I got, what is this? This is nothing but marks minus grand mean, minus grand mean. Now this is not enough. We have to square the result of this one, which is marks minus grand mean. Marks minus grand mean. I'm going to square it because variance is always positive. Okay. So what I'm going to do? Marks 1, 2, 3, 4. Marks minus grand mean. Grand mean square. Square. I'm going to do square. I'm going to do square. Okay. So remember that square. SQUARE. So let's calculate it. Is equal to, now I'm squaring it. This into this itself. Square is nothing but this into this itself. So I got 18225. And now I'm going to drag it because the same way, if I multiply this with this one, I will get this one. Now let's talk about this one. Is equal to this into this and drag it to the bottom. Is equal to the third particular one, this into this. This is 2.25. Now last fourth one is equal to this into this 2.25, sorry, 2.5 into 2.5 is equal to 6.25, then drag it. Now last for fifth one is equal to 4.5 into 4.5, then drag it. Last one is equal to 8.5 into 8.5. So let's, you have got the answer to everything. Now just sum all this, sum all this, sum all this. So sum all this is equal to sum of all the ones, that is square of the difference of grand mean from the marks. So I am summing all this and I'm getting 7387.5. So look at the answer if I'm correct or not. Yes, I got 7388. So I have what you call rounded it. Okay, so you get the same answer 7387.5. So this is the way you have to find, you can find out the sum of squares total. So this is about sum of squares total, sum of squares total, the way you have to calculate sum of squares total. So I will just name it sum of squares total. So hope this part of the discussion is loud and clear. Sum of squares total is calculated. So this is sum of squares total. So sum of squares total is 7387.5. Now let's look at the result. So we have to find out not only the sum of squares of total, but we have to even find out between group sum of squares and even sum of squares within the group. Okay. So our next is between the groups. So I will copy this one once again, and I will show you separately sum of squares between, sum of squares between. Okay. So I am placing this here to calculate sum of squares between. So sum of squares between is nothing but sum of squares between. So this is between A and B, between B and C, between C and D, and is there a variance or not? Is there a variance or not? For this, what you have to find out? First, you have to find out the average of marks secured of black when student was administered Blackboard method of teaching, and average of PPT marks secured by the student when PPT was conducted was used, average of marks secured by the students when video was used, average of marks when the student was administered Blackboard plus PPT, and so on and so forth. So we are first and foremost you have to find out the average of the each group, average of the each group, average of the each group. So let's find out the average of the each group. So I have done the average. I got again 20 only because all the elements are, this is the average. Okay, average. So that I have conducted. So you got 20 average in the first case, second case 30 average, the mean is 35 in the third case, in the fourth case it is 36, in the fourth case 36, in the fifth case it is the average 38 marks, and the last case where Blackboard and PPT were used, and even I think video was used, the average marks were the average or mean is 42. So this is very important. So because we are going to use this particular one. Now, what do you mean by between? Now, between is nothing but first. Okay, we have first. The first step is over. Previously, we even what do you call have found out the grand mean of all the marks, 150 marks, and it was, if I am correct, it was 33.5. Okay, 33.5. Okay, 33.5. So the let's put 33.5. Sorry. So here 33.5 is the grand mean. 33.5 is the grand mean. Okay. This is the grand mean. Grand mean. Let's talk about this one. So what is our headache? One, two, three, four. Our main concern is sum of squares, sum of squares between. So this is our one on which we are discussing sum of squares between. Square between. Okay, so what is the grand mean is 33.5. What about the average? The let's take the average also. The average of group 1, group 2, group 3 is equal to 20, 20, 30, 35, 36, and other, as you can see. So I will go for values. Okay, values. So this is the average. This is the average of group 1, group 2, sorry, group 2, average of group 3, average of group 4, average of group 5, and average of group 6. So now what we have to do? We have to from the mean average mean of each element, each group, sorry, deduct grand mean. Okay, so grand mean will be same in all the cases for all the groups. So I have dragged up to group 6. Next one is I have to find out now grand mean minus average. Grand mean minus average. So I'm taking up this. So that is equal to. So you can have mean average minus grand mean, or grand mean minus average. It will not make any, no, it will not make any difference as of now. So that is equal to. Sorry, just a moment. Is equal to 33.5 minus 20. So I got 13.5, and you can drag. So you got the difference of grand mean minus average. Now what you have to do, you have to square it. You have to square it. So let's square of grand mean minus average. Okay. So let's grab the text. That is equal to 13.5 into 13.5. We got 182.25, and drag it, and you will get 12.25, 2.25, 6.25, 20.25, 72.5. So multiply this one with the number of elements in the group. Number of elements in the group. Number of elements in the group. If you remember, in each element there are 25 students. 25 students. Hope you remember that one. So I have tried it. Now what you have to do? This is now our area on which we are going to work out. This particular data will be used. That is equal to multiply 182.25 into 25. So you will get 756, and I will drag it. I will get figures like this. So now what I have done, this into this. So I will write here also, copy, paste, copy, paste. Then I will copy this one also into multiplied by. So this is the figure I got it. So this is what I'm highlighting, multiplied, because you have to remember that operation was multiplication. Now what you have to do, all the results what I got, I have to just total it. So I will total them. Is equal to, so I will merge, is equal to sum, bracket start, 7526 up to, sorry, sum is equal to sum, bracket start from here till the end. Okay, just a moment. Is equal to sum, bracket start from here to here, and then enter. So I got sum of squares between, I got sum of squares between figure, which is 7387.5, 7387.5. You can see. So let's compare whether I got the same answer or not. So let's go back. So yes, between it is 7387.5. Hope you have understood the mechanism, manual way of calculating ANOVA as far as sum of squares total is concerned and sum of squares between is concerned. Now the next one is sum of squares within. We are going to talk about how did I get this figure of 0. How did I get the figure of 0? So we are going to find out now sum of squares within. Sum of squares within. So I have copied that one. Sum of squares within. So what do you mean by sum of squares within? How this marks, this particular mark 20 is within itself moving from the average of this particular group. Now let's go into the illustration part and let's calculate manually. So first and foremost, I will find out the average of each group. average of each group. Already we have done it, but still average. So average, I got 20. So drag it, you will get average of all the, so group 1, group 2, 1, 2, 3, 4, 5, and 6. So you got the averages of group 1, group 2, and group 3. So I will copy it and I will paste special and values. So I got the average of group 1, group 2, and group 3. Group 1, group 2, and group 3, I got it. 1, 2, 3, 4, 5, and 6. Okay. Hope this is loud and clear. Now, what I have to do? Now, this is the 20. First student has got 20 marks when uh, Blackboard method of teaching was used, and the average of that group was 20. Now, how much this 20 marks? How much this 20 marks? Let me show you with a shape here. How much this 20 marks? Sorry. How much this 20 marks is deviating from the average within. So how much this 20 marks is deviating. In the same way, how this 20 marks deviating from 20. How this 20 marks is deviating from 20. How this 20 marks is deviating from 20. And similarly, how this 30 marks of group 2 is deviating from the average of group 2. How this 30 marks of second student of the second teaching methodology is deviating from the average of 30 marks of second group. So we have to do it on that basis. So what I will do, I will copy the average. I will copy the average and place here and drag. So I will get the averages. So this minus this 20 marks, how it is deviating from the average. How this 20 marks is deviating from the average. That is the reason why I have taken 20. I could have done it in another way, but for simplification and likewise I have taken. So now what I have to do, 20 minus 20, I have to find out how much it is deviating within, okay, the average. So 20 minus 20. In the same way, 30 minus the 30. So here I will take, sorry, I have not taken 30 minus 30, enter. So I will change this to 30. So 0. Next one is equal to 35 minus minus 35 is equal to 35 minus 35. So you will get 0. So here, because I have drawn an arrow, let's remove the arrow. So is equal to 35. First student, when video was administered, 35 marks he got, and how much it is deviating from within the group average. So within is the main important one. So 36 minus 36. For fifth case, 38 is equal to 38 minus 38. Enter. Last one is equal to 42 minus 42. Now what I am doing, I am just dragging it. Even you have to square it, okay? You have to remember this. You have to square this one also, okay? You have to square this one. If you square this one, you will get again 0 only. So, okay, for my purpose, again, I'm squaring is equal to 0 minus, 0 into 0, because I have to square it. So 0. So I will drag it for 6 times below. Below, I will drag it for 25, up to 25 elements, and up to group 6. So how many I've done? 5. 1, 2, 3, 4, 5, and then 6. Now if I total this one, 0 plus 0 plus 0. There is no variance because we have seen there is within the group there is no variance. Is equal to sum bracket start. This one I've summed it and I've got 0. So what I will do, I will merge it. So I will get, I've got 0. So sum of squares within is 0. This is sum of squares within. This is sum of squares within the group. So it is 0. So hope this is also loud and clear to all of you. And this is the way you have to find out sum of squares within, sum of squares between, and sum of squares total. So let's go to the answer, whether we got the same answer or not. Yes, 0. So this is clear. This part, how you got 73, 87, 87.50, 75 degree of freedom, 144, and all that stuff. Now, how did I get this MS between groups of 1478 and MS within groups of 0? Now, to find out this, what I have to do is MS between groups is MS. I will show you here just a moment. Insert MS between groups is, please remember, is equal to what I'm writing. Just see, it is nothing but 7387.5 divided by the degree of freedom. 7387.5 divided by degree of freedom. As far as MS between the groups is concerned, MS means mean sum of squares is equal to, in the second case within groups, MS is mean sum of squares within the groups is equal to uh, 0, this one 0 by 144, or I will write it here, 0 by 144. So let's calculate it. So between groups, MS is equal to this one, that is equal to 7387.5 by degree of freedom between groups. So you remember 1478, you got this. Hope you understood it. Now let's talk about MS within groups is equal to 0 by 144. So hope this part is also clear. Now in the next session, I will talk about this particular remaining part, which is very critical and very important. And then we will going to find out whether the null hypothesis is accepted or otherwise. So if you have any doubts, you can let me know. Thank you so much for patience listening. Bye bye. Take care for, and I will come out with some new videos on the pending topics. Thank you so much.